For decades, scientists have been scratching their heads over Saturn's North Pole. It is home to a gigantic hexagon that has fascinated scientists since it was discovered by Voyager 1 in 1980. But what about the other pole? What lies hidden in Saturn's South Pole? How did this planet manage to form such an unusual phenomenon at its North Pole while keeping its South Pole so different? And how is it possible for these two poles to be so similar yet so different? If you are ready to take a trip through the universe to find out more about Saturn's South Pole, then keep watching. Why does Saturn have a hexagon at its North Pole but not at its South Pole? Scientists do not know the answer to this question. Voyager 1 took the first photo of Saturn's North Pole in 1980. At that time, no one could believe what they were seeing because it was the first time that a spacecraft had ever taken a picture of a planet's pole. They saw a huge regular hexagon that extended 20,000 kilometers from north to south. The edges of the hexagon are smooth, but the interior is quite chaotic. There are storms within the hexagon, but they move in a fairly organized manner. This means that although there are storms, clouds, and fog, the atmosphere of the planet is stable and there are no sudden changes. However, the winds can reach incredible speeds of up to 540 kilometers per hour. That is why the hexagon is also called the jet stream. What exactly is the hexagon made of? Since the discovery of the hexagon, scientists have tried to understand what it is. Some thought it was a vortex like a tornado. Others believed it was several vortices side by side. But in 1990, new pictures showed that the hexagon had not changed in shape in the past 10 years. Therefore, it cannot be just a vortex. Other planets like Jupiter and Neptune also have hexagonal vortices, but they rotate in the opposite direction. In addition, they are not stable and change quickly. So they cannot explain what we see at the North Pole of Saturn. Researchers think that the jet stream is made up of gases that constantly flow from one region of the planet to another. The next big mystery is how long the hexagon has been there. Can it really last forever, or will it eventually disappear? The spacecraft Cassini has been observing the hexagon for many years. It is now known that it has existed for at least 10 years, but it is not known whether it will remain there forever or disappear completely one day. What is certain is that the hexagon has a great influence on the climate of Saturn. It is a boundary between the cold north and the warm south. In fact, the temperature difference between the two regions is about 27 degrees Celsius. The hexagon acts like a barrier, preventing the heat from the south from spreading to the north. But what about the South Pole? There is also a huge storm here. It is also a high-pressure zone, which means that air rises slowly from the bottom of the planet to the surface. As the air rises, it expands and cools, which forms clouds. These clouds reach 3,000 meters in height and form a huge dome above the South Pole. The air inside the dome moves in a strictly circular motion. At first, the storm seemed very similar to those on Earth, but then scientists noticed that it was different. Inside the storm, there is a calm area without clouds. It is like the eye of a cyclone. Here, unlike the North Pole, chaos reigns. There are strong winds, thick clouds, and frequent lightning. The speed of the wind reaches 180 meters per second, which is 648 kilometers per hour. Despite such strong winds, the overall structure remains unchanged. The size of the storm is enormous. It covers almost the entire southern hemisphere of Saturn and lasts for years. Its diameter is more than 30,000 kilometers. For comparison, this is the distance from London to Madrid in Spain. This makes it one of the largest storms in the solar system. Why is the storm at the South Pole of Saturn different from all the others? Scientists think that this is due to the special conditions under which the storm arose. On the one hand, the storm is powered by heat coming from the depths of Saturn. On the other hand, it is influenced by the friction caused by the rotation of the planet. Scientists also believe that the shape of Saturn's poles plays a role in the emergence of such structures. They conducted computer simulations to confirm their hypothesis. Their results showed that if Saturn had a perfectly round pole, the atmosphere would have been turbulent and there would have been no stable vortexes. But the hexagon's sharp corners make it easier for the jet stream to maintain its shape. So, without these corners, it is unlikely that we would see either the hexagon at the North Pole or the huge storm at the South Pole. So, why are the poles of Saturn so different? Scientists suggest that the difference between the poles of Saturn is due to the tilt of the planet's axis. Saturn is tilted 26 degrees relative to the Sun. Due to this tilt, the planet receives uneven amounts of sunlight, which leads to a difference in temperature between the poles. This temperature difference creates a continuous flow of air from the hot south to the cold north. Airflow creates powerful currents, but they do not mix because of the planet's rotation. This results in the formation of vortices. A similar process occurs on Earth when cold and warm air masses meet. Only hurricanes and typhoons arise, but on Saturn, the processes are much more intense. That's why the vortices at the poles of Saturn are so large. The difference in temperature also explains why the vortex at the South Pole is a huge storm. Warm air from the south does not have time to cool down before it reaches the pole. Therefore, it forms a thick layer of clouds. In addition, the rotation of the planet prevents the air from cooling down and dispersing. That's why the storm does not subside for years. The reason for the difference between the poles of Saturn was also explained by an American researcher from the University of California. Richard Gorse believes that the presence of rings around the planet affects the poles differently. He says that the rings affect the properties of the atmosphere near the poles and prevent the air from mixing. This means that the temperature difference between the poles becomes even greater and the vortices spin faster. Gorse believes that the rings also affect the shape of the vortices. They force the air to rise vertically and rotate faster, which leads to the formation of a hexagon at the North Pole and a huge storm at the South Pole. Saturn's poles are still a mystery to scientists. We have a lot of theories, but none of them can fully explain what happens at Saturn's poles. Although Saturn's poles are very different, they are still similar in some ways. Both the hexagon and the storm are giant vortices. They both move counterclockwise in the northern and southern hemispheres, respectively. Both structures are long-lived. They have existed for many years and probably will continue to exist for a long time. Perhaps one day we will be able to unravel all the secrets of Saturn's poles. But for now, they remain one of the most mysterious places in the solar system. Now watch the video about the most terrible storm in the history of mankind. Or check out the video about the amazing planet with two suns.